Welcome back. Well, you knew it couldn't be that easy. So we took some antiderivatives, we evaluated some indefinite integrals with just some basic functions, some basic power rule stuff, some basic trig functions, and what we did was we went ahead and we found out those antiderivatives. Now we're going to be using that, and what our book calls it is our change of variable, or in our indefinite integrals, or what I sometimes refer to as our substitution. What you're going to see a lot of is that they're going to let u be g of x. And what this essentially is going to be the antiderivative for the chain rule. So last semester, if I gave you a function that's f of g of x, don't worry about the constant, but f of g of x, and you took the derivative, it was the derivative of the outside function, which is the lowercase f, at the inside function, which is g of x, times the derivative of the inside function, which is g prime of x. What we're going to do in this semester, and like last semester with the chain rule, I didn't really write down the u value all that often. I just kind of did it intuitively. In this case, what you're going to see me do is oftentimes I'm going to write down the u value. I almost always do, because you're going to have to multiply by different constants, and you're going to have to solve for du and all this kind of stuff. So, and I'm going to do some examples here today for you, and in the examples it'll make a lot more sense. So what we do is we let u be the inside function. We write the function, we rewrite the antiderivative, or we write the derivative, which is the integrand, in terms of u and du, and then we take the antiderivative at u. Still won't be able to just take any antiderivatives. You won't be able to evaluate any integrals, but you'll be able to do a lot more than we could before. So let's take a look at some examples. First of all, I'm going to have the integral of the square root of 5x plus 7 dx. And I'm going to rewrite this way. I'm going to rewrite it as 5x plus 7 to the 1/2 power dx. Now my inside function, the part that's going to be u, is this part right here, which is the 5x plus 7. So I'm going to say, okay, we'll let u equal 5x plus 7. And then you want to take the derivative of this, or du. So you find du, and du is going to be the derivative of 5x plus 7, which is 5 times dx. It's du over dx when I found the derivative. And so then what I want to do is I want to substitute in. I'm going to substitute u for the integrand right here, and I'm going to substitute in for dx. dx is 1/5 of du. So I oftentimes say, okay, well, I need to replace this dx, and what I replace it with is something in terms of du, because I can't integrate if I have an x here and a u here, or vice versa. I can't integrate if I have a u here and a dx here. So I've got to set it as dx equals 1/5 of du. That's just solving this one for dx. Now rewrite your integrand. When you rewrite your integrand, this is the million-dollar question, because if you can do this, you can do everything else. I'm going to take the 1/5 out front because it's a constant. So I'm going to write that as 1/5 times the integral. The integrand is now u to the 1/2 power du. And if you can get this written, if you can rewrite it in terms of u and du, the rest of it just follows our power rules or our trig rules from before. Raise the power by 1, divide by the new power, so it's going to be 1/5 times u to the 3/2, divided by 3/2, plus my constant. Remember that when I divide by 3/2, I multiply by 2/3, so it's 1/5 times 2/3 times u to the 3/2 power, plus my constant. And then ultimately, I'm going to multiply this out, so it's going to be 2/15. And I'm going to put u back in, so it's 5x plus 7 to the 3/2 power. Note that our book and in the answer key and stuff like that, they're going to leave things in terms of u. The AP folks, they're okay as long as you show all your work. I'm going to tell you I'm not okay. I want you to put u back in. So you have to put u back in for me. So it's 2/15 times 5x plus 7 to the 3/2 power plus c. So the big important thing for you to remember in this substitution stuff is identifying u, take the derivative, solve for the dx, or some version of it. You're going to see a more complex example in just a moment. Rewriting it this way. Once I have it rewritten this way, then following power rule or just your simple trig substitution, or your simple trig antiderivative, simplify it down. That's it. In our next example, I'm going to do something in terms of cosine. This is a second example. That 2 is not part of the problem. It's just a second example. It's the cosine of 4x dx. So my inside function this time, my u is the 4x. So u is 4x. du is 4dx. And like I was saying a minute ago, this is not going to allow you to do any function, but it's going to allow you to do a lot of functions. For instance, we don't have an anti-product rule or quotient rule. We actually do. We call it integration by parts. We're going to learn that in May after the AP exam because you're not responsible for it as part of your exam. Now solve this for dx. So dx is 1/4 of du. Rewrite your integral in terms of u and du. So I'm going to take 1/4 out front. That's a constant. The cosine of u du. Please note that you can pull the constant out front, like the 1/4 of du. You can pull that 1/4 out front. The du has to be here. The 1/4 is fine, but if you had like 1/4 x, you can't do that. You can never have a variable in front of your integral. Variables all have to be back here in the integrand. Take the antiderivative of this. Remember that the derivative of sine is cosine, so the antiderivative of cosine is sine. It's not negative, so it's the sine of u plus c. And then what I was just saying a moment ago, I want you to put that 4x back in there for u. So I'm going to write it as 1/4 sine of 4x plus c, and that's my f of x. I could, if I wanted to, like, for instance, I could give you some sort of information about the original function. I could tell you something about the original function, like a point on it, so that you can find my constant value. But I may or may not. You could have some differential equations involving this stuff as well. It's done the same as we did our previous example. Let's take a more complex example. In this particular case, we have to look at which one's going to be a composition of a function. So in this particular case, x cubed minus 3x plus 1 to the 6th power, that's the composition right there. The x squared minus 1 dx, I got to build into my derivative somehow. So it's one of those things where you just got to be really careful. You got to take a look at it. I have a couple different choices. If anything's ever raised to a power, generally we could ask you to square it out, but we wouldn't ask you to raise it to the 6th power, for instance. So pretty clear cut that this part that's in the denominator is going to be u. I'm going to write u to the negative 6th power when I get it. So I have u equals x cubed minus 3x plus 1. Fractional, just a side note, kind of, fractional exponents and negative exponents are your friends. Please write things that way. Take the derivative of that. Du is 3x squared minus 3. That 1 drops out. Dx. And this part right here is close to x squared minus 1, but it's not quite exactly the same. But notice I can make it the same by factoring a 3 out. So I can rewrite this as 3 times x squared minus 1 dx. And now if I solve it for dx, the only constant, the constant I have is the 3 right there, so it's going to be 1/3 of du. And the x squared minus 1 dx is going to be my numerator right there. I'm going to replace that piece right there with 1/3 of du. So ultimately, 1/3 of du is x squared minus 1 dx. Rewrite the integrand in terms of u and du. The 1/3 goes out front. This is going to be 1 over u to the 6th, so it's u to the negative 6th du. And like I was saying, that it's that part that you have to write. That's the hard part of this whole problem. I can't pull any variables out front. I've got to accomplish all of this stuff within this derivative right here. Now I can follow my power rule. Make sure you add 1 to this power, not subtract. Add 1 to this power. Can't tell you how many people make simple mistakes of taking derivatives, not integrals. So it's going to be 1/3 times u to the negative 5th over negative 5 plus my constant. Ultimately, you probably see the answer written this way on a multiple choice test. It's going to be 1 over this when I multiply it out. It's going to be negative, so 15 out front, parentheses. I'm going to put my x cubed minus 3x back in, x cubed minus 3x plus 1. And that's going to be raised to the 5th power. That negative 5, put that back down in the denominator, plus the constant, and that's my original function f of x. So in terms of rewriting things in terms of U and DU, and you're going to see me do this throughout the semester, we do integration by hand quite a bit, and then after we get through the integration by hand, we start doing it on our calculator. We get a little spoiled, but you're going to see me rewrite this in terms of U and DU, and as we go along, I'll start skipping more and more steps. So you got to make sure to stop me if you're not sure. Please ask questions about it in class, or please stop me as I'm going through this, and or take a look at maybe some more videos on Khan Academy or some other of the sites if you're not sure of what I'm trying to explain, and they can help you along. Best of luck on that second assignment. I think that's it. Yes, it is.